Hello, and welcome to the first lab challenge of this series. The steps for solving this challenge will be narrated step by step along the way. The first step involves reading and analyzing the problem, which is to design and implement an ESP32 circuit with 4 toggle switches as input devices and 8 LEDs, with 4 of them being green and the other 4 as red. The condition is that a toggle switch can only be turned on only once, meaning if switch 1 is turned, then the rest of the switches are off. Aside from the problem description, the specifications were also provided as shown here. Moving on towards the next step, the students opened up the WOKWI simulator and searched for the required components. These include 4 toggle switches, 8 LEDs with the first being green LEDs, and the other 4 being red. A resistor is also required to restrict excess current from breaking the LEDs. After choosing the components, they are placed inside the simulation area. Next, the proper wirings for VCC are connected to each toggle switch, specifically to the rightmost pin. The voltage source comes from the 5-volt output coming directly from the ESP32. Proper grounding connection is also considered by connecting the leftmost pin of each toggle switch to the ground pin coming directly from the ESP32. Afterwards, the data pins for the toggle switch represented as an input are connected to each middle pin of every toggle switch. Pins 2, 4, 5, and 18 were selected for this challenge. After confirming the proper wiring connections for the toggle switches, the proper connection for the LEDs are next in line. The negative pin for each of the LEDs are connected to form a common ground, which simplifies the connection to proper grounding. The resistor is also connected to ensure the stability of the LEDs. Once that's done, the students proceed to connect the positive pin of each LED to their corresponding GPIO pin on the ESP32. For the green LEDs, pins 19, 21, 22, and 23 were used. The red LEDs, on the other hand, were connected to pins 12 to 15 respectively. Now let's move on to the last step, which is to check for any wiring errors and confirm that everything is correct. After doing so, the steps for building this circuit is finished. Hooray! Now, to continue with the lab challenge, let us move forward to coding the software that will command the ESP32 and hardware components to produce our desired LED output. To start off with any sketch in Arduino IDE, the students first included the two default functions which are setup and loop. Code inside the setup function will only run once, while code inside the loop function repeats indefinitely unless modified. Next step is to define the toggle switches, LEDs, and lighting sequences that are represented as states as shown in the problem description and specification. This is done by creating different arrays that correspond to the pins assigned to the toggle switches and LEDs. Additionally, a global timer variable was initialized to set the delay for every sequence to 500 milliseconds or half a second. After defining the needed arrays, the components are then initialized in the setup function. By using a for loop, the shortened code can be used to initialize the corresponding toggle switch pins as inputs, while the LED pins are set as outputs. Do take note that adding comments using two forward slashes can be a helpful tool for debugging and sharing the code to other peers. For the next step, additional variables are created for storing the state of the toggle switch pin to the digital read function. To produce various functions that depend on which toggle switch is on, four conditional if statements were created. If only switch 1 is turned on, then a for loop is run that processes the pin sequences found in the state 1 green and state 1 red arrays for the LEDs. The indexes for every element in the array are then manipulated to produce the desired LED lighting sequence. The digital write function is used to either turn the LED on or off, depending on the sequence. Lastly, a delay function is included to set the timing between the LED transitions. The same steps are done, for the if statements used for switches 2, 3, and 4. The only difference is that different arrays are used to represent the other states. State 2 green and state 2 red is used when switch 2 is turned on and etc. Moving on to the last step, the code must be evaluated and checked for any errors while confirming the proper functionality. After doing so, the steps for writing the code is finished. Bam! Thank you for joining us today, and we hope that this video has been helpful and educational. Stay tuned for more videos just like this one.